In this introductory video on the Tankless unit, we introduce the engineering scheme beneath the unit and review the components inside and the role they play in its operation. In the next video, we put everything together and discuss how the whole unit works. You should have already viewed the misting fundamentals videos, and since our Tankless unit shares a lot of the same components as our drum units, you should go back and view that video if you haven't already. Let's get started by talking about the general engineering scheme of our unit. Dosing a drum-based unit is considered a batch process. The technician starts with a recipe for the mist, that is, how much insecticide he should add to a given amount of water in order to achieve a target concentration of active ingredients in the mist. When refilling the unit, he builds a new batch of dilute insecticide by adding a known amount of fresh water along with a known amount of concentrated insecticide. Assuming the ingredients get mixed and stay mixed, as our agitated drums do, the whole batch conforms to that recipe. Conceptually, our Tankless unit operates exactly the same way, as a batch process. It also starts with a recipe that the technician programs into the controller. The water is supplied by a connection to a water faucet that is always on. The concentrated insecticide is supplied in a bottle that is plugged into the unit. When it comes time to build a batch, the controller opens a valve which allows a known amount of fresh water to enter a reservoir. The controller consults the recipe and then calculates how much concentrated insecticide should be added to meet the recipe. It then activates a dosing pump, which adds the insecticide. After that, the unit mixes the contents of the reservoir and the batch is ready to mist. The first thing you'll probably notice about Gen 3 Plus is that it is much smaller and has a lower profile than our drum units. And because it's not a big, black, 55-gallon drum, it offers a generally more finished look. The cabinet and lid are fabricated from metal with a high-quality powder coat. Note the hand grips that allow you to pick up and carry the unit. At the bottom, on the right side of the unit, you'll see two ports. One port accepts quarter-inch tubing and supplies the nozzle circuit. The other port has a push-to-connect fitting that will accept 3/8-inch tubing from the water faucet. At the faucet, you'll see an adapter that converts the standard hose fitting to a push-to-connect fitting for 3/8-inch tubing. You can also buy a Y connector with two ports, each with a gate valve. You can put the adapter on one of those ports to supply the unit with water, while also providing a port for the garden hose. As you follow the tubing to the unit, you'll also see a filter that is spliced into the tubing just upstream of the unit. This filter traps sediment in the water before it can reach the components in the unit, and it is very important to remember to install it. Both the adapter and filter are included in what we call the finish kit that comes with the unit. Now look at the lid. The lid is sloped to shed rainwater. You'll note a lock set on the front of the unit that allows the lid to be locked. Poking through the lid is the antenna that gathers a radio signal sent from a handheld remote. Now let's open the lid. This molded piece of black plastic is what we call the shroud, because it hides most of the components of the system. The shroud rests on 4 threaded metal posts and is secured with knobs that you can remove without a tool. The digital controller is recessed into a cavity in the shroud and held with 4 threaded fasteners. The controller hardware is actually identical to the controller in the Gen 1.3 drum unit, but it is programmed with different software. You will also notice a well in the part of the shroud nearest the front of the unit and a coupler with a button on top. The bottle containing the concentrated insecticide plugs into the coupler and rests in this well, like so. Pushing this button on top of the coupler releases the bottle. Now let's take a closer look at the bottle. These are what is known as tip and measure bottles, and they are very commonly used to contain and measure pesticides. You'll see 2 ports on the bottle. The vertical port accepts what we call a plus cap, which is also included in the finish kit. You thread the plus cap on like so. We've already seen that you can snap it into the coupler. The other port accepts a vented cap. This cap provides a vent to the atmosphere that prevents the bottle from collapsing when the dosing pump in the Gen 3 Plus pumps the concentrated insecticide out of the bottle and into the batch tank. The misting insecticides packaged in tip and measure bottles are generally available through MistAway or pesticide distributors. We also supply an empty 1 gallon size tip and measure bottle that also accepts the plus cap, and you can transfer material into that as a service container. If you do use a service container, it is important that you only use products that are labeled for use in automated residential misting systems and that you secure a copy of the label to the bottle. Now let's go into the shroud. There are 2 ways of getting access to the components hidden by the shroud. The easiest way is to first release the bottle from the coupling, then remove the fasteners that pin the shroud to the unit, and then remove the screws securing the controller to the shroud. Then push the controller back into its own cavity and rotate the right edge of the shroud clockwise, letting it rest on the left wall of the unit. You can perform every maintenance task you'll need to through this access. Alternatively, you can leave the bottle, shroud, and controller in their places and remove the sidewalls. You can completely remove the sidewalls by backing out the screws that secure it to the base and back of the unit. Doing it this way will allow us to view all the components in place. Let's talk briefly about what we will see. There are actually 3 what we call subsystems of components in our tankless unit. The misting subsystem agitates the dilute insecticide in the batch tank and then pumps it out through the nozzle circuit. And its components and operation are virtually identical to our agitated drum unit. The fresh water subsystem adds a known amount of fresh water to the batch tank, playing the same role as a technician that adds a known volume of water to a drum unit from a garden hose. The concentrate subsystem adds a known amount of insecticide in the way that meets the mix recipe, just like the technician that measures and pours a known volume of insecticide in a drum. Let's look at each of those subsystems in turn. This schematic shows the components in the misting subsystem. In the intro to our Gen 1.3 drum unit, we've already gone over how the unit agitates the water insecticide mixture in a reservoir and then atomizes it out through the nozzle circuit, while preventing dripping nozzles and siphons. Gen 3 Plus contains almost all of the same components that our drum systems do, and it works identically. You should recognize all of these components: the reservoir, the pump intake and filter, the auto drain valve, the agitation valve and line, and the pump and motor. There are really only 2 differences between Gen 3 Plus and Gen 1.3. One is that the reservoir is 2 gallons rather than 55. We sized the tank at 2 gallons because a batch that size is large enough to handle the largest nozzle circuits. The other difference is that the agitation line does not have a mixing adductor. Since we are only trying to stir up 2 gallons and not 55, the unit just doesn't require one. Now let's look at where they are in the unit. Here is the motor and pump in the back left corner of the unit. The 2-gallon reservoir is on the right side of the unit, and you'll see the pump intake and filter. Here's the auto drain valve. This is the agitation valve, exactly the same one that appears in the agitated Gen 1.3, and the agitation line, but no mixing eductor. Now let's move on to the fresh water subsystem. This system starts at the water faucet. When the controller opens what is called the supply solenoid valve, water flows from the faucet through the 3/8-inch line, through the inlet water supply filter, which screens sediment from the downstream components. The water then flows through the supply valve and then through an electronic flow meter. The flow meter measures the flow by counting the revolutions in a pinwheel contained in the meter. The water then goes through a flow regulator, which throttles the flow if it is too turbulent. The water then drops across a 2-inch air gap and into the reservoir. An electronic switch in the reservoir contains a small float, and when the fluid in the reservoir pushes the float up against the stop, it sends a signal to the controller, indicating the reservoir is full of fluid. The purpose of the air gap is to meet backflow prevention requirements in the plumbing code for devices that are connected directly to municipal water supplies. The concern that drives this requirement is that a break in the water line upstream of a device could cause a vacuum that might, in our case, suck the dilute insecticide in the reservoir back through the water line and faucet and into the city water supply. The air gap we've engineered into the unit meets all the relevant plumbing codes for backflow prevention. And we have prepared engineering drawings that are available to present to inspectors who may have questions around backflow protection for the unit. Now let's look at where the components of the freshwater subsystem are positioned. Of course, the water faucet, 3/8-inch line, and inlet filter are outside of the unit. The supply valve is mounted to the back of the unit at the right rear corner. Water flows through this valve up through the flow meter. There are two 90-degree turns in the line to position the flow regulator and air gap so that the water drops into the reservoir, like so. The float switch is secured to a bracket that is mounted to a batch tank and is positioned so that the float hits against the stop when the fluid pushes the float up. Now let's move on to the concentrate subsystem. This subsystem consists of the tip and measure bottle with the plus cap plugged into the coupler. Then tubing connects the coupler to the inlet of the dosing pump, and some more tubing carries the fluid from the discharge side of the dosing pump into the batch tank. Now let's look at the actual components and watch the subsystem at work. As we've discussed, here's the tip and measure bottle with the plus cap plugged into the coupler. Next, on the other side of the shroud, you can see the dark colored tubing that connects the coupler to the intake of the dosing pump. On the discharge side of the pump, there is clear tubing that leads to an entry into the batch tank. Since the tubing is clear, you can visually confirm that the dosing pump is working by activating a dosing cycle. Now let's look at the pump in action. The Gen 3 Plus uses what is called a bellows pump. These are the bellows. There is a small motor in the pump that turns a cam that first elongates the bellows and then compresses them. When the bellows are pulled apart, insecticide is pulled inside, and when the bellows are pushed together, the insecticide is squeezed out of the other side of the pump. The bellows has a set volume and the motor turns at a set rate, which means the pump offers a known, very precise, repeatable flow rate. Okay, we've covered the overall engineering scheme for the tankless unit, as well as reviewed the important subsystems: misting, fresh water, and concentrate. In the next video, we'll put everything together and discuss how the subsystems operate together to make the unit work.